a little recap of this morning. If we were expanding this completely, we would know here that this one has 4 terms. And this is in your textbook, so you don't have to write anything down. And you could use Pascal's triangle, since there's 4 terms, to see those green numbers, that it's going to be 1, 3, 3, 1. Then the first term in your binomial is 2c to the 4. You would start with 3 of those, then 2, then 1, and then you wouldn't have any. And the second term, underlined in red, is the -1. You would start with none of those in the first term, then you have 1, then 2, then 3. And afterwards, you simplify. So this is quicker than actually expanding it out, but it ends up being a big number in the end. So sometimes when we have things like 3x plus 5 to the 12, how many terms are there going to be? 13 terms. How many rows of Pascal's triangle are you going to have to make? Lots. And the numbers are going to get big even when you're adding them, so it's going to get a little bit annoying. So what we end up doing with bigger questions like that is they say, let's just find a specific one. Let's just say, could you find, for example, in this one, could you have found just the 3rd term? And then you don't need to do all the work. We just need to find a shorter way just to find the 3rd one. Well, we do that by recognizing some of the patterns that we've seen throughout. What are some of the patterns we've noticed? Well, the combinations, the numbers in front, are related to combinations. And those combinations, like this 3 right here, this is 3 choose 2. So how do we find out, if we want to find the 9th term in this one, how do we find out what is going to be the combination in front? So in this one, if I wanted to find the 9th term, does it make sense to you that I would have 12 choose 8 as the number that would be in front? Because if we go back to our example and look at our green numbers here, this number was 3 choose 0. This number is 3 choose 1, 3 choose 2, and this one 3 choose 3. So one of the things that we find out is that if we're finding the 9th term, this number in front, well, the 12 comes from whatever exponent you're using, and this number here is always 1 less. The next thing we had was in blue, so I'll do it in blue here. Our first term is 3 to the x. If you were finding the 9th term, what number would there be? How many 3 to the x's would there be? Well, you would start with 9, and then you would have 8, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2. So in the 9th one, there's going to be how many?
0.
Well, I'm going to point something out using this number and this number. Can you see that this is 3 minus 0? I mean, that's, and this, using those two numbers, this is 3 minus 1. And this number, we only have one of them, happens to be 3 minus 2. So if we have 12 choose 8, our exponent in the 9th term will be the 4th. There'll be 4 of them in the 9th term, or 12 minus 8. Even easier to see is the second number, in this case is our 5, which I'll do in red just to match what we've done before, is that our second term, if you went to the 9th term, how many will there be? Well, there's 0 in the first term, 1 in the second one, 2 in the third one. There's going to be 8 in the 9th term.
So whatever you're minusing, 12 minus 8 is 12 minus 10 is what is 5 at the end.
So now we have to take this idea and put it into a formula. And that's what they have right here, the general term in the expansion. And we're also going to write this. We're sort of going to ignore the form that they have here and just teach you the form that you're going to get on your formula sheet, which uses a plus b, I think. Yes. So right beside this or right underneath it where you have room, I want you to write for a plus b to the n, so they have x plus y to the n. For a plus b to the n, on your formula sheet they have term k plus 1 is equal to n choose k, a to the n minus k, b to the k. So if I was trying to find, like I did in my example before, if I'm trying to find term 9 in an expansion, let me just rewrite what we were finding before, 3x plus 5 to the 12. So if I have 3x plus 5 to the 12, if I'm trying to find term 9, can you see that k is 8, 1 less? And earlier I talked about some things being 1 more and some things being 1 less. This is a place where k is 1 less. So if I'm finding term 9, because it's k plus 1 here, k is equal to 8. Your n always comes from your exponent. So it's going to be 12, choose, and k is 1 less. Your a value is whatever your first term is, so for us, it's 3x, n minus k, 12 minus 8. Our b value is our second term. In this case, it's 5 to the power 8. And then you simplify each of these things separately, and then we'll take one extra step to combine them. And that is how this formula, and this is the formula on your formula sheet, how it works. Yes. I just chose a random one, because there's going to be 13 terms here. And so on an exam, you only have a certain amount of time. And they're like, if we asked you to find all 13, that might take a long time, and it would take a lot of simplifying and just be a 15-minute question. And if you can get term 3, you probably can get term 4, and then you're just wasting your time showing the same skill over and over again. So what we're doing is we're saying, well, if we look at the pattern of what happens, if we look at the pattern how these blue numbers went down by 1, the red numbers go up by 1, the green number in front is a combination. How can we use a specific term and figure out a formula for that? And the formula that we get, which is on your formula sheet, is this one in the black box. They don't give you this part. You have to know that part, but they give you the rest. What's that? Do you want me to simplify it? So then, if we were simplifying this one completely, well, I want to find term 9. I would go to my calculator and figure out what 12 choose 8 is. I get 495. I'll put that in brackets, because again, each of these things that I've underlined in red, green, and blue, you would do separately. So you do this one first. This is going to be the power 4, 12 minus 8. 3 to the 4 is 81, x to the 4. And then the blue one, 5 to the 8. Again, you'd go to your calculator. That's equal to 390,625. So once you've simplified each one individually, now we combine it together, multiply all your coefficients. So we're going to get a huge number, because 495 times 81 times 390,625. It's so big it gives a 1.566 times 10 to the 10, and then we still have an x to the 4. So you will get some answers with very, very large numbers in this section.
That's why it doesn't matter exactly what these last few digits are.
So here, let's look at example 3 with not as crazy numbers. It happens to be the 9th term again, That's kind of just coincidence. So you would have your formula on your formula sheet. I'll rewrite it here. On your formula sheet, you have this formula. You want to find term 9. So if I want to find term 9, that already tells me my k value is going to be 8. So I know that this is going to be 8. My n value comes from my exponent. My exponent is 10, so my n value is 10. So I start with 10, choose 8. A represents the first term in my binomial, which is x, and it's going to be to the power of n minus k, or 10 minus 8. B represents our second value, and whenever there's a subtraction sign, we put the negative with that second value, and it's going to be to the power of 8. We figure out each of these things separately first. So term 9, 10 choose 8, that's 45. X squared, and negative 2 to the power of 8 is 256. Just double check that. A negative number to an even exponent will always be positive. A negative number to an odd exponent will always be negative. So we simplify each one separately. Now we multiply our numbers together. We put our variables together. There's only the x squared. So I'll go to my calculator again. 256 times 45. And term 9 is equal to 11,520 x squared. So now we're not finding all the terms, we're finding a specific term. It's quicker because we can use a formula, but that formula comes from the patterns we noticed when we did it entirely. So try right now questions 5 and 11.